Very good evening, ladies and gentlemen. I am Bhashini Jaitunga and I will be the host for today's session. It's my pleasure to welcome you all for the first session of IEEES workshop series organized by the Electrical and Electronic Engineering Society of University of Peradeniya. So as we all know, the undergraduate years are the perfect time to establish in ourselves the values and practices that promote success in research. So this webinar is conducted to start you off on the right path. So the topic for the today's session is how to become a successful researcher at every stage of your career. So before moving on, I would like to invite Mr. Dinusha Lakshan, Vice President of Electrical and Electronic Engineering Society of University of Peradeniya, to welcome you all to the session.
Thank you. Am I audible, Bhashini?
Yes, you are audible.
Okay, thank you. Good evening to all of you. I am extremely overwhelmed today to get this opportunity to welcome you all to start our first workshop from our workshop series carried out by Electrical and Electronic Society, University of Peradeniya. We have organized a wonderful session today to guide you on the process, how our first research is carried out, and how publications are done, and to apprise you the impact of a research. So this will be a very helpful session to all the undergraduates here. On behalf of the Electrical and Electronic Society, first of all, I would like to welcome our chief guest, Chair Professor, University of Peradeniya, Professor Janaka Ekanayake, for this graceful occasion. Next, I would like to welcome the guest of honor, Senior Treasurer and the Advisor of the Electrical and Electronic Society, University of Peradeniya, Dr. Prabal Bindeva, all the committee members of Electrical and Electronic Society who are present here today. I warmly welcome them for this occasion. Last but not least, I would like to welcome all the participated graduates and students here. Finally, once again, I warmly welcome you all to this live session on how to be a good researcher. Thank you all. Over to you, Bhashini.
Thank you so much. So without taking much time, with great honor, let me introduce the guest speaker today, Professor Janaka Ekanayake, who will deliver a remarkable session. So Professor Janaka Ekanayake is a Fellow of IEEE, IET and IESL, and he's the Chair Professor of Electrical and Electronic Engineering of University of Peradeniya. He is also a visiting professor at Cardiff University, UK and University Tenaga, National Malaysia. He has published more than 75 papers in refereed journals and also co-authored 6 books. He is recognized as the most outstanding senior researcher in the field of engineering through the CVCD Excellence Award in 2018. Professor Ekanayake is an expert on renewable energy, their connection and modern power system, and he has received many presidential awards for scientific research. So dear sir, it's a great privilege to have a person like you in today's session, and again I warmly welcome you. Before moving on, I would like to remind you that there will be a Q&A session at the end. So please feel free to send your problems through the chat box. Now I would like to invite Professor Janaka Ekanayake to carry on the session. Over to you, sir.
Thank you very much for that nice introduction. Let me share my slides. Can you see the slides, please?
Yes, sir.
Okay, thank you. So let me straight away move on to the presentation. Today I had to rush to this one. My brother-in-law has to be hospitalized for not a serious issue, but I just came from the hospital, so I'm not in the attire suited for a chief guest. So just assume that I am one of the professors at Electrical and Electronic Engineering Department, who also a member of this society. Right. In the presentation, I'm going to cover, give a very brief introduction, even though sorry, I couldn't get your name. the lady who introduced me gave a the very comprehensive introduction, but just I'm going to touch upon the question, am I qualified to discuss this topic, and the tips to be a good researcher. And also I wanted to dedicate this presentation to my guru, who taught me the iron of research, who is our late Professor W.P. Jayasekara. If I take you through my journey, I was attached to the Department of Electrical and Electronic Engineering. For 7, during our time, there was no COVID, but we had to stay 7 years to get the degree. I eventually got the degree in 1992 with the first class honors. Then I went to, I was, absorbed to the university as a lecturer probationary right after my exams. And I served there in the university for 2 years, and then I left to UK, to University of Manchester Institute of Science and Technology. Interestingly, Dr. Bindu and myself got PhDs from the same place. Then returned to Peradeniya in 1995, and I was a senior lecturer at Peradeniya till 2003. Then 2003, I was promoted to a professor, and I served the university as a professor for 4 years and decided to leave Peradeniya. So I quit the job at Peradeniya, went and joined Cardiff University, UK, served there for several years, and I got my permanent residency on somewhere in 2013. I can't remember the exact date, but once I got the permanent residency, next day I left Cardiff and came and rejoined Peradeniya as a professor of electrical and electronic engineering. And meantime, I got the Fellow of IET, Fellow of IESL, and Fellow of IEEE. And what is not shown here is a couple of days ago, I was promoted to a senior professor. And as one of your colleagues mentioned, I'm among the top 2% scientists in the world as a Scopus database. Got the most outstanding senior researcher in 2018, NSF Research Award for Scientific Excellence in 2018, many presidential award, and many individual National Energy Symposium. So that just to show you that I was an ordinary student like you, long time ago, but that came through various encounters and finally became a recognized researcher in the area that I'm serving. So I would assume that I can speak about this topic, and I hope that you will learn something from what I'm going to talk to you just now. Now, we'll start with some tips to be a good researcher. Now, the first thing is we need to be systematic. Now, one of the main problems in some of our researchers is they try to take shortcuts in order to, get certain things, get certain outputs quickly. Of course, in the today's world, you can take shortcuts, but on long run, that's going to work against you. So what do you mean by systematic? Now, the research, if you look at the research process, the research is always originated by an idea. Then you convert that into some questions or problems. Then you do a thorough literature review to see what else people have done in this particular area and then try to refine, you will read some good journal papers and you will refine your idea. And this cycle will continue right through a research process, whether it's at the beginning of your research process or at the end. Now, once you get the refined questions and problems, then you can plan and design your research. So there are large number of ways you can approach your research questions, and it's important that we select the right method and tool for the successful completion of our research. And again, your literature review will help you to refine the methods. There are, if you find that whatever the technique that you are using has been applied before and you have a better way to solve the same problem, you may select that path. Now we know that so some of the things we have been doing in the past using analytical techniques and modeling techniques today being replaced by AI techniques. So, you can optimize the processes, you can expedite the processes, and all that comes under the plan and design stage. Then you generate results, and finally you interpret results and draw conclusions. Now, whether it's a research paper or a research grant, this process is pretty much valid. Sometimes you don't draw conclusions from your results. Sometimes you add a lot of your own ideas which are not backed by results, and that is something we should not do in a proper systematic research cycle. Let me take you through an example to highlight this process. Now, we had a long time ago, now it's been abandoned, but I took this as an example. We had an idea to build a power plant in Sampur, a large coal power plant, which was originally 900 megawatt, then went up to 1,200 megawatt. So the CEB was looking for ways to bring that power to the load center, which is the Colombo. So they decided to build a new line from Sampur to New Habarana. From New Habarana, you have 220 kV links to Colombo city. But the difference was the original plan, they were planning to increase the voltage that is being used in the country to 400 kV. And if this line would have come, that would have been the only 400 kV line of 95 kilometers. The zebra is the conductor, and this line carries 4 zebras. In other words, you might, if you have seen, on a cross, each end will carry a conductor, and each of these conductors are zebra. So that is the line which was planned with this addition of coal power. But this, as I told you, this is an old story, because the new government in somewhere in July 2021 decided that we will not add any more coal power plant to Sri Lankan network. So, but I thought this would be a good example to show you the research process. Now, the primary question one may ask, CEB came up with 400 kV. Why can't we use 220 kV? What was the limitation? Are there any mitigation technique that allows us to stay with 220? Remember, immediately after we go to 400 kV, the towers become taller, the protection and all the other issues become different. So CEB does not have the expertise or the experience of working with such high voltage lines. So why we wanted to get into a new territory, which is unknown to us, if we can live with the existing territory. So that was the immediate question which comes to somebody's mind. So when you do a literature review, you will notice that there is a concept called series compensation. I will show you in a minute, which is been in commercial use since early 1960s. It enables increase of power transmission capacity of a line. It increases the steady state stability limit, and it provides the dynamic stability. So the immediate question is, can't we use series compensation, which reduce the transmission reactance, to use the same line, 220 kV line, for transferring power from Sampur to New Habaran? So when you do a little bit more, you will see that now this is the typical equation that governs, that shows the power transfer from one point to another. Vs is the sending end voltage, Vr is the receiving end voltage, and XL is the line impedance. But what happens is, if when you add series compensation, the series compensation will change the impedance of the line from original XL to XL minus XC, so that you can very clearly see that the numerator has reduced, which means P will increase. So with this one, P will increase. So that was the idea of series compensation. And as I told, this is a well-known concept. And this is a series compensation system applied in, you will find many in Brazil, many in, the countries where there are large, long lines. So this is, the one can immediately see why we need to jump into 400 kV. Why can't we stay with 220 kV with series compensation? So this is what basically what series compensation means. It allows us to change the capacitance by having capacitors in stages with back-to-back thyristor control reactor. So when this reactor is on, you are taking off the capacity in series with the line. When this is off, you add the capacity in series with the line, and you can do that in stages. And that, like the total XC, which is added by the series capacitor divided by the line impedance, is called the series compensation level, which is usually defined by a percentage. So the refined research questions are, can series compensation achieve the power level anticipated in the line? Remember, as I told you, we wanted to transfer 1200 megawatt from Sampur to Colombo. So if yes, what is the optimum compensation level? As I told you, XC or XL can be set, and what should be the size of that compensator? And how do we compare the economics of a 220 kV line with series compensation and a 400 kV line without any compensation? So these are the refined questions. So then you define the methodology. You would do test studies for line loadability and voltage collapse for 220 kV transmission line without any series compensation, and then with series compensation and 400 kV line. Then you will do load flows, and you will, try with different compensation levels. And finally, you will do an economic study. So that's the kind of methodology. So in order to obtain the line loadability, you can use the simple theoretical line loadability limit, and there are the ways to get the practical line loadability. And what you are seeing here is the red one is if you use 2 Zebra 400 kV. So you can see that if you try to transfer 900 megawatt, the bus voltage with this line will drop to 1 per unit. Now, if you use the 4 Zebra 220 kV line, you can very clearly see that, within reasonable limits, you cannot obtain more than 775 megawatt. So that clearly shows that, simple 4 Zebra 220 kV will not work. You will need a 4 Zebra 400 kV because we want to transfer, remember, 1200 megawatt from Sampur to New Habarana. So that line will go up here, so can support 1200. Yeah, 4 Zebra can go up to 1103, which is good enough for most of the operating scenarios. But if you add the series compensation at different percentage, you can see that the blue line here can be shifted upward with the same 4 Zebra 220 kV, and at around 20, this is around 50% compensation, you can reach a higher power levels. So, yeah, this is the 4 Zebra. You can go up to up to 2,530 practical steady state stability limit. So you can see that we can load the line if we have the right compensation. Then, of course, you can do some load flows and to see what are the real voltages under different operating scenarios. And then we do an economic study. And what you see here is, if you constructed the 4 Zebra 400 kV line, the total cost is 1.1 million 263 206 million LKR. So it's a huge amount, but that is the kind of money CB is spending for these lines. If you use 220 kV with 50% compensation, you can see that immediately the cost will go up by 500,000 million LKR. And that will, at the break-even year, the 50% compensation will not have a break-even year up to 6 years. So you can clearly see that you can use 200 kV 4 Zebra conductor instead of a 400 kV 4 Zebra conductor. However, it's not economical to go for 4 Zebra sorry, this should be 220 kV, 220 kV with compensation because of the economic reason. So that justify the original proposal by the CEB, but this is what I am showing you is a simple research study to support that justification. So you can simply see the sequence of events that took place on this systematic research design. The second one is your research should be timely. What I meant by timely, now we know that we are depending 100% on imported fossil fuel, especially our transport sector. That is why when the petrol prices go up, the three-wheeler guys will charge more, the buses will charge more, because we all depend on 100. But there is the crisis situation we are in, because we don't have adequate foreign currency to purchase imported oil. So we will have transport issues. Now, this particular slide I created last year when I did this presentation. Now, today, I can confirm this situation, not for the transport sector, but for the CEB, because according to the current figures, the CEB will not have coal to run our coal power plant, the Norachole coal power plant, for beyond April of this year, next year. And in order to purchase coal, to run it right through the year, the CEB will require $280 million US. And CEB requested from the governor, central bank governor, and he said that there are no dollars. So today I saw this has been probably leaked to the newspapers, and the newspapers are saying that we will soon have power cuts. I mean, we are not talking about half an hour, 1 hour kind of power cuts. We are talking about long period power cuts. So in the case of transport sector, of course, we have a solution which is promoting electric vehicles. But the problem with electrical vehicle is if you try to charge your electric vehicles using the coal power plant, then you are producing more carbon dioxide. At the same time, you are again going to depend on dollars. So why not use some solar photovoltaic? So we came up with two designs. Now this is the present charging mechanism. This is in fact, I have this system at home. You have a solar PV system, which is connected to the AC bus bar, and EV is connected to the again AC bus bar through a converter. So you can see that there's a DC-DC converter, there's a DC to AC converter, and there's a AC to DC converter involved in present scenario. Each of these converter add losses. Now, one of the proposed system could be without converting the direct current coming from solar panel to AC, you can connect your EVs directly to a DC bus, which is connected to a DC-DC converter. So you can see that number of converters has reduced. If it is only, one EV connection, you can even get rid of one of those. And the losses in these converters has also will be reduced. So there are timely research available for this particular question. So the next one is the publications. Now, if you don't have good publications, nobody recognizes you as a good researcher. Your credibility depends on the publications. In fact, I'm happy to say that was it yesterday? The day before yesterday, I hit 100 publications. These are high-end journal publications. I hit 100 thanks to a lot of my students. Now, there are ways that we can publish papers. You can publish review papers. So-called review papers mean when you start the literature review, you would review hundreds and hundreds of papers. You arrange them in a systematic manner and you can write good review paper. They are well recognized, and writing a review paper is very difficult compared to a usual technical paper. Then if you have a bit of simulation, you can go for a good conference paper. But if you can support that simulation by theoretical background, you can obviously go for a journal paper. But if you also can add some practical work, you can hit a high quality journals. Now, it is easy to publish in new areas. If you can relate your work to COVID-19, the publications was very easy, but now it's again becoming competitive because COVID has been there for more than 2 years now. So, as I said, academics with top-rated papers in top-rated journals usually get recognition, grants, and students. And this, simple cartoon from PhD comics shows that your research cycle. You read, you write, you rinse, and you repeat. So that's basically what you are doing. But remember, by the time you finish writing, you will realize that somebody else has written your idea. Then, of course, you need to repeat the cycle from the scratch, and that is why it says rinse. Only by writing papers regularly, you can master the art of scientific publishing. You can write journal papers, but even still, I can't write good journal papers. There are always issues. So in order to be a master of writing scientific publications, that is a different art one has to learn. You must publish as much as you can. So when you think about a good journal paper, think what is the novelty of the work that you have done? Does your work contribute to advance the state of the art in your field, and how? Is your work different from your competitors, and how? What are the unique selling points of your work? And you define the structure. Don't put the flesh initially. So when you define the structure by first, populating different sections, and then using breakdowns of sections and paragraphs, and finally you can, add flesh into it, and always remember who is your audience when you are writing. So a paper must meet 4 criteria before it is publishable. The content of the paper must match the scope of the journal. So selecting the right journal for your paper is very important. Don't just send it to any journal. The quality of the paper must be sufficiently high. We do, some silly mistakes and assume that, you can get away with that silly mistake, but usually, when it goes to when those silly mistakes add a negative impression of your paper. For example, one of the silly mistakes that our civil engineers have done, when somebody enter into the country, when you come out from the airport, at Katunayake, you will find a big green color board which gives directions to Colombo, and directions are given in Kelvin meters, capital K, simple M. I never know how to measure distance in Kelvin meters. I know how to measure distance in kilometers, which is simple K, simple M. So that's a silly mistake. I'm sure our engineers know how to write kilometers, but I'm sure even you are doing that kind of stuff. Do not do silly mistakes. So the quality is very important. And it must present, or it must contain some novel results, and the result must be significant enough to be worth reading. The common reason for rejection: the article topic is not within journal scope. Article type does not match what the journal usually publishes. Article does not follow basic journal guidelines. The writing does not meet basic standards. Problem with references, and more importantly, plagiarism and self-plagiarism. What it means is, I'm sure most of you know what is meant by plagiarism in this Google world. You can Google something and cut and paste into your paper, and whenever it goes through a plagiarism counter, it will show high plagiarism count, and journals will straight away reject those papers. Now, what is meant by self-plagiarism? You quote your own work. You cannot like, you can use your own work up to a certain extent, but your paper should not have more than 30% overlap with another paper you have published. I mean, I am just giving this 30% with my experience. It can be 40, still can be accepted, but chances for acceptance will reduce once you start adding more and more of your work into the paper, published work into your paper. So this is the journal cycle. You submit a paper, editor will do a pre-selection, and editor can straight away reject your paper and decline, decide and notify the author, or it can assign reviewers, and the review process will start, and reviewers can directly reject the paper or accept the paper with minor revisions, major revisions. There are different ways. So you can revise and resubmit, and then again it will go to the reviewer. And if the paper is in the right, everything is done, then the journal will accept your paper. Now, it's very important that when you are doing the revised version of the paper, you address the reviewer's comment very carefully, because never try to give answers to reviewers' comment. Reviewer might say something which is completely untrue, but you need to be diplomatic. Don't say that you don't know the subject. I know it. That's why I wrote it like this, and that's the end of the story. You will never get that paper published. Never challenge the reviewer. Always add the comment to the paper. Don't write long sentences to tell the reviewer, you are wrong, because of this reason, I have calculated this, and it is very clear that this is wrong, and so on. Just use the manuscript. Now here you can see that in order to clarify these ambiguities in the original manuscript, paragraphs were added to the introduction section with better and deeper analysis of state-of-the-art SC algorithm. So you can see that we don't say, when you read this, thank you for your comment. The authors realized that there was a lack of explanation regarding the exact novelty of the paper. You always take the blame to your side. Don't tell that you reviewer don't know anything. The diplomatic way of giving this answer will, because remember that the second time, usually reviewer will not go through the paper again. He will carefully go through his own comments and see how the authors have addressed it. And if he is satisfied with what we call the response to reviewer document, he will simply say, I accept it. And your work could be good. It is systematic, it's timely, it has a lot of publication, but that's not enough. The good researchers should be known by the people. So the impact is something which is very important. If there are no impact from your work, nobody will know. People are there, so very good researchers, published work, and if somebody asks, who is the authority of that area in University of Peradeniya, nobody knows this guy because he has never come out with any impacts. Just wanted to highlight you when somebody talks about impact, these two scenarios. Assume that there are two researchers. The both of them are, having very good education qualifications. Their profiles are identical. Now, one of them applied for a research grant to work on a specific disease that reduces the milk production of cows by 10%. There's another professor applied for a research grant to work on the psychological situation. You know that when the baby cow is born, the cow is separated from the mother, so that mother will produce more milk and the company can get more milk from the mother. So there is a psychological situation here where the cows, when their calf is born, when they are separated. So now the question is, now both these say that both these goes to a funding agency, and the funding agency have limited funds. The question would have been which project they will support. Now, the reason why I took these two cases, if you go into certain countries like the countries which doesn't care about the human values or the cow's values or anything, who cares about the economic impact of the research, obviously they will support Professor A. The reason is the Professor A will increase the production of that milk by 10% once he finishes research. I mean, that research methodology can be then applied to the industry, and industry can increase its milk production. But having said that, there are countries which consider the psychological situation of cows. For example, in India, they consider cow as a sacred animal. So, they might support Professor B. So outputs and impacts will depend on the cultural nature of countries and cultural nature of funding agencies. So we cannot say that this is because this is good, it will definitely be recognized by the society. It depends on where you are. Now, if Professor B is a good researcher, goes to the country where Professor A is in and apply for this one, he will never get money. So outputs are not adequate. You should have outcomes from your research, which is understanding and awareness, economic impacts, impacts on public policy and services, impact on society, culture and creativity, health impacts, impacts on practitioners and professional services, and impacts on the environment. This is a simple example. I'm going to highlight you about the economic impacts. This is a research impact Dr. Bindu Hewa, Professor Lilant and myself did. This is a typical load distribution in a bank. You can see that 72% of the load is air conditioning and office appliances. Then there are other office appliances. No, sorry, this is air conditioning. There probably a mistake. And this is office appliances. These are the other appliances, and these are the lights. And we know that in a bank, the operations are daytime, and LED, the lamps are normally LED. Air conditioners are, the modern banks will have inverter controlled air conditioners. So why not, rather than using the present approach where I was showing you with EV, you convert the solar power into AC and convert AC back into DC when you are using. Why don't you use a DC microgrid where you don't have any AC except the utility grid, which is also connected to DC, where you connect all the bank loads into that DC bus bars. Now, the advantage here is particularly advantageous for a bank because the operation is daytime where the PV is available. And as I told, the lighting is, even though it's LED lights are now connected to AC circuits, inside you have a rectifier to convert AC into DC. The same with the inverter control air conditioner, same with your laptop. same with your computer, the desktop computer, same with your printer. Everywhere you have a AC to DC converter, and that's basically killing certain amount of energy. So if you use this DC microgrid concept, your bank will have a 25 energy reduction. That will be very useful for the bank to reduce the energy usage. And it's very important that we align our research with current topics. For example, I started my career as a I worked on a renewable energy plant back in 1995 situated in Denmark. But then I realized that there are more room for grid integration of renewables, so I moved on to that area. Then realized that there is the leverage for smart grid with the renewable energy additions. So start doing research on smart grid, and now more recently I start working on AI applications in smart grid. And once I get into AI with the AI expert in the department, we said, why not try AI applications in other areas? And more recently, we got this new project where we are doing AI applications for COVID. It's a Canadian grant, fairly good grant. 4 researchers are working with me. If you have time, go to this website. Unfortunately, during a weekend, PDN websites are not working. I'm sure Tuesday, they will fix it. So you can find some of our work there. So basically, that's it. Even though you have not seen the middle picture, this is the Walla with the famous rosea tree, which we lost. I can't remember exactly, but I think it was between 2007 and 2013, because when I left Peradeniya, it was there. When I came back Peradeniya, it wasn't there. So with that, I will open the floor for questions. Thank you for giving me this opportunity to share my experiences with you guys.
Thank you very much, sir, for sharing a valuable knowledge and experiences with us. So now it is the time to start the Q&A session. So we got several questions from our participants today. So the first question is, what is the major difference between good research and a good project?
Good research and good project. I mean, project could be anything. A project could be if you wanted to start a beauty salon, it's a project. There's no research involved. If you wanted to build the bridge, it's a project. There's no research involved. The research means which we call it the exploratory study, which has certain component of exploring things.
Thank you very much, sir. So the next question is, after doing a project, what are the necessary steps which are needed to publish a paper from that project?
Yeah, again, I will, the difference between the project and the research project is very important. If you can do a project, for example, some of my undergraduate students last year did a project. What we did was, there was a electric vehicle in one of the factories. We changed the battery setup in those electric vehicles, and obviously there is no paper in it because it was just a project. There was no research component. However, when we did that, we installed some sensors to gather data, and analyzing that data and doing some predictions is a component of research. So in order to publish your project, you need to think about the research cycle I explained before, and it should have good results, and your results should be highlighted against the existing work that are out there. If you can show a novelty in your work, you can go for a journal. If there's no real novelty, but work is good, you can go for a conference. I hope that.
Thank you very much, sir. So there is another question. Sir, can you recommend some websites which are suitable to do a good literature review? And is there any criteria for choosing good journal papers?
Yeah, I mean, we electrical engineers usually use IEEE Explorer to get good journal papers. Now I know that you somehow found what do you call it, the cracked base of reaching the IEEE Explorer. Otherwise, you need to pay for it. So IEEE Explorer is the best way to find good journal papers. Having said that, there are new journals which are open source, but remember, you need to you can guarantee that IEEE papers are still maintain certain standard. But if you go for an open source, you need to look at the authors and also the content to decide the good journal papers to read. But it's kind of coming with your experience. You will start knowing the people who are working in your area, so you can do a search based on their names. The B, you start knowing the good journals in your area. So these are coming with the experience, and your supervisors can always help you.
So there is another question. What are the costs behind publishing is high impact journals? For example, IEEE.
Okay, there's no cost for publishing in IEEE. IEEE still maintain free publications, but usual acceptance rate in good IEEE journals is around 16%. So it's very tough to publish in IEEE. But if you wanted to publish quickly, remember IEEE journal papers would take from 6 months to 9 months, depending on the journal. Some journals are a little quicker. But if you wanted to publish your work quickly, you can go for other publishers such as NDPI and so on. They will charge, somewhere around $2,000 to $3,000. It depends on the different journals, but it's expensive.
Someone asking that he has a question regarding the example that you provided about the coal power plant in Sampur. Did we consider about implementing HVDC lines?
No, HVDC lines, we don't have long lines in Sri Lanka. The longest line right now is from Kotmale to New Anuradhapura, somewhere around 75 kilometers. And if you could remember, the Sampur to New Habaran line is around 96 kilometers. So there is no justification for HVDC for that line of that nature. If you wanted to go for HVDC on a the overhead line, the distances we are talking about is more than 500 kilometers. So in Sri Lanka, we will not have any chance of having the HVDC lines for power transmission. Having said that, there was a proposal to build a line between Sri Lanka and India. Now, when it comes to the submarine cables, HVDC becomes cheaper for lines greater than 50 kilometers. For For submarine cables, it's 50 kilometers. For overhead lines, it's around 500 or 600 kilometers. So we will never have HVDCs on ground, but we may have this line to India.
Thank you, sir. There is one question more. Kindly explain the process of review papers, preferably with an example.
Okay. Now, I mean, I'm sure you might have heard that the new concept, which is called blockchains. The blockchain is a way of doing transactions using some, we basically using cryptocurrency, and there are a lot of applications in blockchains merging, but in power systems, blockchain has become an applications for peer-to-peer. Like if you have a house next door which has more energy, they can sell that energy to the neighboring houses. And how do you charge for that energy? And for that, the blockchain came as a method. So if you do a survey on blockchain applications for power systems, you can see a paper which is a survey on blockchain for future smart grid, technical aspects, application, integration challenges, and future research. You can see that this is a few researchers in Sri Lanka, and of course everybody is Sri Lankans. And when you look at those kind of papers, what you find is usually you come up with the different areas associated with your topic in hand, which is the smart grid. And the blockchain will become one of the key areas in the smart grid, specifically for peer-to-peer the transactions. So you can do a thorough literature review. And if I go to the number of papers you need to add into a paper like this. So here you can see that these are all references. And if you count them, I'm sure there are more than 100 references. Otherwise, you need to consider every aspect of blockchains related to the topic in hand and give as much as journal papers to support your ideas. So that is basically the idea of blockchain. Sorry, review papers.
Thank you very much, sir. And that is the end of the Q&A session. So we are really thankful to you for delivering such an important session today. It's an honor to have you with us on today's webinar. On behalf of the Electrical and Electronic Engineering Society, I sincerely appreciate you for taking out time from your busy schedule to provide us with such a valuable information. So, dear participants, we highly value your ideas and thoughts about today's session. Therefore, we kindly request you to provide with us your feedback through the provided link in the chat box. And now I invite Ms. Chathumi Vijayapala, the Assistant Treasurer of Electrical and Electronic Engineering Society, University of Peradeniya, to deliver the vote of thanks.
Thank you, Bashini. So, ladies and gentlemen, a very good evening. It gives me an immense pleasure to deliver the vote of thanks for the first session of the Electrical and Electronic Engineering Society workshop series. Therefore, on behalf of the Electrical and Electronic Engineering Society, I would like to express my gratitude to our chief guest today, Chair Professor Janaka Ekanayake, Department of Electrical and Electronic Engineering, University of Peradeniya, today for joining us. And also, this is the very first session of EEES workshop series. Thank you very much, sir, for joining today and sharing your valuable experience and inspirational knowledge with us. Following that, I would like to express my sincere thanks to Dr. Prabhat Binduheva, the Senior Treasurer and the Advisor of Electrical and Electronic Engineering Society, University of Peradeniya, for his unwavering support and direction all throughout, as well as the committee members of the Society for their tireless efforts. Last but not by any means the least, I would be grateful for each and every individual who participated today and helped to make this event a great success, and it is truly appreciated. Once again, I thank one and all present here. Thank you. Vashini, over to you.
Thank you so much, Shadme. So we have come to the end of today's program. And before leaving, we kindly request you to provide us with your feedback through the provided link in the chat box. Hope to see you in our upcoming sessions as well. Keep in touch. Good night.
Thank you, everybody.